Out on the open waters of the South China Sea, a modern warship is only as deadly as the weapons defending its perimeter. Yet many coastal patrol crews are still forced to fight exposed to the elements. Standing behind an open mount on a rolling deck in heavy swell, a sailor operating a manual heavy machine gun faces severe fatigue and compromised accuracy. For years, the Philippine Navy addressed this critical vulnerability by purchasing advanced remote weapon stations from foreign contractors. Importing systems like the Israeli Rafael Mini Typhoon or European alternatives solved the accuracy dilemma by moving the gunner inside an armored cabin, but it came with a staggering price tag. Procuring a single high-tier imported remote mount can cost between $450,000 and $650,000 United States dollars, translating to roughly 25 to 35 million Philippine pesos per unit. When factoring in specialized overseas logistics, proprietary replacement parts, and extended maintenance downtime, outfitting dozens of coastal patrol craft becomes economically unsustainable for a developing defense budget. To break this costly cycle and secure its vast maritime borders, the government in Manila chose a radical alternative. Developed through a joint initiative between the Department of Science and Technology Metals Industry Research and Development Center and the Philippine Navy, Project BUHAWI was engineered to deliver precise, automated fire support at less than half the acquisition cost of overseas counterparts. By integrating reliable 50 caliber firepower into an indigenous stabilized mount, the Philippine defense establishment initiated a major shift towards self-reliance. Before we go on, do you think developing nations should build their own automated weapons or rely on proven foreign technology? And tell me where you are watching from. Subscribe to our channel to stay updated with our latest defense analyses. Engineered as a direct answer to foreign dependency, the acronym BUHAWI stands for Building a Universal Mount for Heavy Barrel Automated Weapon Integration. At its core, the platform combines mechanical engineering from the Metals Industry Research and Development Center with targeting algorithms created alongside the Mechatronics and Robotics Society of the Philippines. The system integrates the combat-proven Browning M2HB heavy machine gun, chambered in 12.7 by 99 mm NATO standard ammunition. Delivering a sustained rate of fire between 450 and 550 rounds per minute, it commands an effective maximum range of 1,800 meters. The motorized mount provides full 360-degree continuous traverse and an elevation arc from -20 degrees down to +60 degrees, allowing operators to neutralize high-speed surface craft or engage low-flying reconnaissance drones. The optical suite incorporates a high-definition daylight camera, a forward-looking infrared thermal imaging sensor for zero-visibility nighttime operations, and a precision laser rangefinder tied to an onboard digital ballistic computer. To validate its capability in challenging maritime environments, the Philippine Navy mounted the prototype onto patrol craft BRP Heracleo Alano PC-376 for live fire sea trials in April 2022. Operating in open waters near Corregidor Island, the weapon station was tested against dynamic surface targets under sea state 3 conditions, characterized by wind speeds up to 16 kilometers per hour and ocean wave crests exceeding 1 meter. The integrated 2-axis gyro-stabilizer instantly countered roll and pitch motions, maintaining lock on target and achieving shot groupings comparable to Western standard remote stations. By proving that indigenous software and domestic precision machinery could survive brutal maritime vibrations, The trials demonstrated that local engineering was ready for frontline naval service. The financial breakthrough of this domestic automated mount fundamentally alters the naval acquisition equation. Developing the prototype required an initial research investment of approximately 14 million Philippine pesos, which translates to roughly 250,000 United States dollars. When transition into serial mass production commenced, the unit cost dropped further to around 12 million Philippine pesos, or approximately 210,000 United States dollars. Compared to imported remote weapon stations commanding over $500,000 per mount, the military saves more than 50% on hardware costs alone. Following the official technology handover in May 2022, defense leadership moved swiftly to place an initial production order for 10 units to equip frontline patrol boats. Beyond capital acquisition savings, domestic ownership creates an immediate logistics advantage. Imported weapon systems routinely force naval commands into costly supply chain bottlenecks, where replacement circuit boards or custom mechanical actuators require export authorizations and take 6 to 12 months to arrive from overseas depots. The domestic system relies entirely on local precision fabricators and technicians based in Manila and Cavite, allowing maintenance crews to return damaged or worn mounts to operational status within days. This cost efficiency enables an asymmetric coastal doctrine tailored for archipelagic defense. Instead of concentrating vital firepower on a handful of large frigates that remain vulnerable to saturation strikes, naval strategists can distribute dozens of automated heavy machine gun mounts across lighter platforms, including Jose Andrada-class patrol craft, high-speed interdiction vessels, and coastal patrol craft. By dispersing stabilized, accurate .50 caliber firepower across multiple coordinated hulls, small naval units can form rapid swarm formations to patrol shallow reef channels, monitor exclusive economic zones, and counter gray zone maritime incursions effectively without risking multi-million-dollar assets. The operational success of this automated mount serves as a flagship case study under the Self-Reliant Defense Posture Revitalization Act, officially enacted as Republic Act 12,024. This landmark legislation mandates a strict domestic preference policy across all armed forces procurement programs, ensuring national research centers receive dedicated funding to modernize legacy platforms. Demonstrating immediate cross-service adaptability, the core robotics and stabilizing algorithms were swiftly shared with the Philippine Army under Project COBRA, designating controller-operated battle-ready armament. Following comprehensive live fire field trials at Camp O'Donnell in Tarlac, ground forces successfully integrated these remote turrets onto M113A2 tracked armored personnel carriers and Simba combat vehicles, shielding infantry gunners from direct exposure during urban clearing and reconnaissance operations. Looking ahead, defense engineers are already exploring upgraded variants capable of mounting 20mm autocannons or modular anti-armor missiles, alongside testing unmanned surface vessels configured for autonomous littoral patrol missions. The overarching strategic lesson is clear. True national defense capability does not always depend on purchasing multi-million-dollar flagship platforms from foreign suppliers. For an archipelagic nation facing severe maritime security challenges, mastering the design, software algorithms, and domestic maintenance of practical automated weapon stations provides sustainable resilience and long-term tactical autonomy. Will indigenous cost-effective automation prove sufficient to deter advanced naval powers in disputed waters? Or must middle powers continue relying on costly foreign alliances and imported combat systems to guarantee sovereignty? Share your perspective in the comments below.